Hello, everyone. Today, I'm going to start my lecture with something interesting. We see various phenomena every day. It's not our intention. When you happen to see new things or something interesting, would you have any question or personal idea about these observations? If no, no new findings. If yes, perhaps you will have something new. The development of science depends on our power of observation and also the ability of creative thinking. Long ago, some interesting phenomena were observed. The amber could attract some bits of dry leaves. In the rainy day, lightning appeared in the sky. What's the law governing this phenomena? This is the focus of today's topic, electricity. You may have such an experience. When you take off your sweater, some sparks could be seen at night. Here are two pictures. A comb attracts bits of paper. I believe some of you have the same experience when your parents brought you to the science museum. When you touch this instrument, your hair will stand up. So fantastic! What's the physics behind these phenomena? Any idea about them? All of these phenomena are related to electricity. In order to explain the natural phenomena observed by chance, some experiments will be intentionally designed to improve our understanding on the observations. For example, a rubber rod is rubbed with fur, and a glass rod is rubbed by silk. When a rubber rod is placed near a glass rod, they will attract each other. On the other hand, when two rubber rods or two glass rods moved close to each other, repelling between two rods occurs. You may notice two experimental facts: attraction and repulsion. How to explain these findings? When can the interaction between two rods be either attraction or repulsion? In other words, the interaction indicates that there exists a force between two rods. The questions you may like to ask: what is the difference in the force that is responsible for the different interactions observed in the experiment? Where does the force come from? Is the electric force originated from electric charges? We understand better on the observed experimental facts by applying a model or developing a theory. There are two types of charges in nature, which we call positive charge and negative charge. What's the origin of electric charges? We know all materials are made up of atoms. An atom is composed of a nucleus and the surrounding electrons. A proton carries a positive charge, and a neutron is a neutral particle with no net electric charge. An electron carries a negative charge, which is equivalent to the charge of the proton. It's noted that an atom is neutral, which means the number of electrons equals the number of protons in the atom. Hence, if an atom loses its electrons, it would be positively charged. If an atom captures the extra electrons, it would be negatively charged because of the excess electrons. Let's review the facts of this experiment again. When the rods are rubbed, they will be electrically charged, suggesting the rod carrying extra electric charges, and net charge on the rods is no longer zero. As a result, the rubbed rubber rod carries the negative charges, and the rubbed glass rod carries positive charges. When the rubber rod and the glass rod are approaching each other, the attractive electrostatic interaction causes two rods to attract each other. The rubber rods will repel each other due to the repulsive electrostatic interaction between two rods. Based on these observations, we conclude that the charges of the same sign repel one another, while the charges with opposite signs attract one another. Now we have a question. the rods would be electrically charged when they are rubbed. Does that mean the charges are created by this process? It also was found that the total amount of charges in the isolated system will not change. The charge will not be created but transferred from object to another. Electric charge is always conserved in the isolated system. For example, when the glass rod is rubbed by a silk cloth, the glass rod lost the electrons and the equal amount of the positive charges was left. It was positively charged. The silk cloth received the electrons from the glass rod, which was negatively charged. The number of electrons transferred from the glass rod to the silk cloth is identical to the number of electrons that the silk cloth got. There was no extra charge created during this process. Only a charge transferring process occurred. It was discovered that the amount of an electric charge is not arbitrary. It always equals integral multiplies of the elementary charge, E. In other words, the electric charge Q is said to be quantized. An electron has a charge of minus E and a proton has a charge of plus E. They have the equal magnitude but opposite signs. We know that the electrostatic force exists between charged objects according to the experimental observations. But how to determine the magnitude and the direction of the electrostatic force between charges? We'll talk about it next week.